So we're going to talk about the differences between a frame, a truss, and a machine. So trusses, frames, and machines all serve different functions. So trusses and frames. The primary function of a truss and a frame is to support load. So, so they typically support loads, and the goal typically is to support a given load while minimizing the weight of the truss or the machine, all right, or of the frame. So both trusses and frames serve the same function. A machine, the goal of a machine is to transmit and alter forces. All right, I should say alter the effect of forces. All right. So for a truss, we've been talking about in the last few lectures. A truss, the primary assumption of a truss is that each member within a truss is only a two-force member, meaning that it is either in tension or it is in compression. Right. While for a frame, um, many of the members within a frame, or at least one member in the frame, has to have three. So members will typically have uh, greater than or equal to three forces being applied to them. All right, so that's the primary difference between um, to a truss, a member within a truss versus a member within a frame. And then machines will typically have greater than or equal to three forces at least acting on one member. All right. So so because of these differences, how you analyze these machines will be slightly different. So we've already covered for trusses how you can use the method of joints, and you can use the method of sections to evaluate the forces within each of the truss members. For frames and for machines, they will share the very similar analysis. They will share the same analysis technique. They'll be a little bit slightly different from what we've done before, but it's not too different. The first thing you'll do is you'll just draw a free body diagram. All right, and then the second thing you're going to do is you're going to set the sum of all the forces, or you're going to say that the resultant force, sum of the forces, or the resultant force is equal to 0. While you'll set the sum of the moments about a point, or the resultant moment would be equal to 0. So it should be the sum of the moments plus the sum of any couple moments on the system should be equal to 0. All right, and you'd use the same technique for a machine as you would to analyze a frame. All right. For so in order to analyze a frame and a machine, first thing you'll do here, or one thing I want to point out here, is that it's not a completely new thing. You've already done this to some extent in chapter 5. All right, we talked about rigid body equilibrium. All right, so the only difference we're doing here in chapter 6 to analyze frames and machines, instead of having in chapter 5 we had one rigid body. All right, now for a frame and machine we have multiple combinations, or we have greater than one rigid body must be analyzed in order to determine the forces within the members of the frame and the machine. All right, so it's just a combination of things that you've already done. All right. So So you can think about it as that you're just doing multiple problems within chapter 5 problems within the same problem. All right. So the steps are going to be very similar. So the first step is that you need to draw the outline shape of your frame or machine. You can, after you draw the outline shape, you should then draw all the applied forces and couple moments to the part, and you should define a XYZ coordinate system. After that, you have to add all supporting reaction forces and moments and assume the direction of those supporting reactions. Once you do that, you should then identify any two force members within the frame or the machine, and draw the line of action through the two joints where they connect. This will reduce the number of equilibrium equations you might need to apply. It'll hopefully make your life a lot simpler. So please do make sure that you do try to identify all the two force members. And then once you have so there's so sometimes these you're gonna have rigid bodies will be connected at often at joints. So oftentimes they will share forces at those contacts. So if you have any two contacting members, so they could be contacting through a pin or through a roller or through a any other joint, they could be fixed to each other. They will have equal and opposite the forces that contact both of them will be equal and opposite. So you can either treat these forces in two ways. Okay, so you can treat all the force. So you can treat you can analyze multiple rigid bodies as a single rigid body, meaning that you can just draw the free body diagram of everything within it. We just did that technique when we were analyzing a truss. We just took the entire truss, all the members that are connected together, and we treated it as a single rigid body, and then we could ignore all the internal forces. Or you can isolate each rigid body, and you can then in that sense you have to account for these internal forces and treat them as external forces. All right. So we're going to go through some examples of that and how you can treat these as both a single rigid body and as a combination of individual rigid bodies. All right. And then typically for frames and machines, unless you're specifically told to include it, you can ignore the weight of the frame and machine. All right. All right. So the next thing basically is once you have your free body diagram, all right, is all right. Once you have your free body diagram drawn, you could then have to just apply your equilibrium equations. All right, so make sure that you count the number of unknowns on each body and determine whether or not you can solve it. So in 2D, the most unknowns you could solve for would be 3, and you could apply these equations to solve for them. So you could sum all the forces in the y direction. Sum of the forces in the x direction is equal to 0. The sum of the forces in the y direction is equal to 0. And the sum of the moments about the z-axis has to be equal to 0 for 2D. All right. So in 3D, all right, you could solve for up to 6 unknowns. So you could say that our resultant force is equal to 0I plus 0J plus 0K. So you have an x, a y, and a z component, so that would give you 3 unknowns you could solve for. And then for the resultant moment about a point, all right, we also know that that would be equal to 0 in the x, y, and z direction. All right. All right. All right, so when you're taking the moment in these types of problems, make sure that you take the moment about a point that is convenient. So if there's an intersection or a point where multiple unknown forces are intersecting, that will make your analysis easier. So you should take the moments about that point. All right, and yeah, and then of course if you solve your equilibrium equations and you end up getting a force with a negative magnitude, that what that means is that, or a moment is that the forces are actually acting in the opposite direction, as shown in the free body diagram. All right. All right, so that concludes this video, and then we're going to do a couple example problems on frames and machines.